Point -4,3 is on the terminal point of an angle in standard position. To the nearest tenth of a radian, find the possible values of theta in the domain from -2 pi to 2 pi. We've had this same question in 6.1 in degrees. We had to draw a triangle. Where's -4, 3? Here's my angle in standard position, but anytime I draw a terminal arm, I can always make a right angle triangle back to my x-axis where I label my reference angle. I know that this length is 4, this length is 3. A squared plus b squared equals c squared. This length will be 5. And if I wanted to find out what my reference angle is, I could use sine, cos, or tan. For example, tan of my reference angle is opposite over adjacent. And so how would you find your reference angle if you were in degrees? Well, you would go to your calculator and you would go tan inverse of, is it 4 over 3 or 3 over 4? 3 over 4. And that would tell you your angle in degrees. But since my calculator's in radians, when I push enter, it tells me the angle in radians. And so my reference angle is 0.643. And that's going to feel weird because you don't know what that angle is, right? If you wanted to know what it is in degrees, we could do it. I could just go to my mode button, go back, change to degrees, type in the same thing again and say, oh, you meant 37 degrees. That makes more sense to me. 0.643 radians doesn't really make much sense to me right now. But we're going to start thinking in radians. So just to have it here, I'm going to put this as approximately 37 degrees just to help us visualize it. If I wanted to find this green angle, how would you do that if it was in degrees? You would do 180 minus 37 degrees. So now that I'm in radians, I'm going to do pi minus 0.643. So I'm going to go to my calculator. I'm actually going to go pi minus this answer. And my one answer is 2.5 to the nearest tenth. That would be the only answer between 0 and, remember, all the way around would be 2 pi. We also need to figure out this possibility, the negative angle. If you were dealing in degrees, can you see that you would do 180 plus 37 degrees? But now that you're dealing in radians, you're going to do 180, or sorry, pi plus 0.643. So I go back to my calculator, pi plus, and I should have stored this value so I didn't have to always go back and get it. 3.79 going in negative direction. The red angle, negative 3.8 radians. So we did the same question in radians like we would have done it in degrees. So we have to be really good at the process of saying, I know how I would do this if it was degrees, and now I can do the same process in radians as well. And the more we practice with radians, the quicker you're going to get to solving these questions in radians as well. So part B, given cotangent of theta is equal to -2, if cotangent of theta is equal to -2, then tangent of theta, notice the angle didn't change, but I can do the reciprocal of the angle. Then tangent of theta is equal to -1/2. The first thing you always find is your reference angle and when finding a reference angle, do tan inverse, and that has to always be positive inside. And so I can go to my calculator. Tan inverse of 1/2, that's in degrees. I should be in radians. Tan inverse of 1/2 in radians tells me my reference angle is 0.464. But if tan is negative, according to your cast rule, that means you should be looking in quadrants 2 and 4. This question gave us the domain from -2 pi to 2 pi. So in quadrant 2, you have a reference angle. In quadrant 4, you have your reference angle. How are we going to find all of our answers? In the positive direction, I would have pi minus my reference angle and 2 pi minus my reference angle. Just like you would have 360 minus your reference angle and 180 minus your reference angle. And in the negative direction, it's just going to be your reference angle times that's negative, and here I do 180 plus my reference angle. And so since the bell rang, I will just show you the answers here. We won't actually calculate them all.
Students, please report to the office for messages. Piper Bailey, Brandon Henry, Harriet Olson.
And your questions for practice on this one are 13 and 14.